We've been talking a lot about federal bills, and this particular one is a state one. One of the things that we've discovered over the last quarter century is that as the federal government has gotten out of the business of legislating about the environment, states and communities have gotten into the business. And so this is really part of New York State's overall energy program, and it's a proposal within that. So we'll hear from our briefer right now.
Good morning, and thank you all so much for being here. My name is Tavo Truankala, and for the next 10 minutes, I will be introducing you to the New York State Clean Energy Tech Production Program. This program is proposed by New York Assembly Bill 1705B and would encourage large energy users to implement programs that design and use renewable energy and energy efficiency measures at their facilities. As Dr. Cohen mentioned, it fits in with New York's broader efforts to change the way that electricity is produced and used within the state. To introduce this bill, I will be answering three main questions. First, what environmental problem does the bill address? Next, how does the bill propose to address these problems? And finally, how will the bill's success be measured? In answering these three questions, I hope to convey to you the potential that this bill has to help move New York towards a cleaner and better energy future. So first, what problem does the bill address? And particularly, what environmental issue is targeted? Why is this issue a problem? And what are the negative impacts associated with the issue? The environmental problem that's targeted is the impact of electric generation from fossil fuels, and in particular, we'll focus on natural gas. The reason we're focusing on natural gas is because over the past few decades, the generation of electricity from natural gas has been increasing in New York State, as you can see in the graph on the left. The red vertical line shows 2005, where that increase really accelerated thanks to the hydraulic fracturing revolution, which made natural gas abundant and cheap. And this has led to the point, by 2016, 42% of the electricity generated within New York State came from natural gas, which is the largest of any source, and that level is about the same today. And why is this a problem? There are two primary concerns associated with natural gas generated electricity. The first is the impacts of the extraction of natural gas, primarily through hydraulic fracturing, or fracking as it's known. And the second is the combustion of this natural gas to generate electricity. Both of these processes lead to environmental impacts that can be felt at the local and global scale. So what are the impacts of extraction? The development of wells and the associated access roads can fracture previously continuous landscapes, as you can see from the picture above. While this fragmentation may only disturb a small percentage of the overall land cover, it can still have significant impacts on the local flora and fauna. The drilling process itself can lead to fugitive methane emissions. Methane is the primary component of natural gas, and once it's released to the atmosphere, it acts as a potent greenhouse gas, contributing to the acceleration of global climate change. The drilling process also involves the use of large volumes of water. This water is mixed with many hazardous chemicals, and while much of this water is recovered and treated after its use, some of it can escape and enter the local environment and even reach drinking water supplies, causing human health impacts. And there are also issues associated with combustion. While many people consider natural gas to be a clean fossil fuel, the fact remains that burning natural gas to generate electricity emits pollutants. Of primary concern are carbon dioxide, which is another greenhouse gas that, once it reaches the atmosphere, contributes to the acceleration of global climate change, and nitrogen oxides. Nitrogen oxides are by themselves a pollutant, but when they're emitted, they can also react with the local air to create particulate matter and ozone. These three contaminants are all respiratory irritants that can lead to short and long-term human health effects. So after that brief introduction to the environmental problem that we're trying to address, we'll now shift to talking about the bill itself, and in particular, how does the bill propose to address this, with what solutions, how would these solutions be implemented, and why a bill like this is necessary in the first place. The bill proposes to reduce the impact of natural gas in two primary ways. And first is increased generation from renewable sources. A shift from natural gas and the associated impacts to renewable energy sources will help to minimize the environmental consequences of our electric generation. While hydropower is currently the largest renewable energy source in New York State, this bill focuses on technologies such as wind and solar, which really have the potential for growth within the state. The second solution proposed to reduce the impacts of natural gas is a reduction of electricity usage, and in particular, electricity generated from natural gas and other fossil fuel sources. The bill proposes a number of strategies to accomplish these reductions, including energy efficiency, advanced energy management, and distributed energy resources. The graph that you can see here shows two potential outcomes for electric usage in New York. The dark blue line at the top shows what electric usage would be like over the next 10 years if we did not implement some of these strategies, while the light blue line shows the impact of these strategies being implemented. As you can see, by 2028, there's a difference of almost 20,000 gigawatt hours, which for reference is about 1/8 of the total statewide electric usage in 2017. So these strategies can really have a good impact. And how would the bill implement these solutions? The bill proposes to establish what's known as a self-direct program that would apply to large energy users, those with 2 megawatts or more of demand. For reference, that's about 2,000, the average usage or demand of 2,000 New York homes. But many of these large users are significantly greater than that. The program would be funded by clean energy surcharges, which these large users, and in fact everyone in New York, pays on their electric bill. Currently, these charges go into a statewide clean energy fund, which then implements a number of programs that are meant to improve efficiency and renewable energy. But a self-direct program allows the large users to have more flexibility to design programs that are suited to their unique needs. It can also help lower administrative costs while still holding the large users accountable for the environmental benefits that these projects are meant to have. And so why is a bill like this necessary in the first place? As I touched on briefly before, the current state programs are not well suited to the large energy users. One example of this is that only 9% of the funds distributed for clean energy capacity by the New York Green Bank in 2016 went to large industrial and commercial users. This is a problem because these large users represent a significant portion of New York's overall electric usage. In 2016, they made up 63% of the electricity sold. So if New York State is going to meet the ambitious energy and emissions reductions goals that it's set for itself, it must target this large chunk of the overall electric sector. And in order to have a successful bill, you have to understand what success means and how it will be measured. To understand this, we'll look at the desired outcomes of the bill, how these outcomes will be measured, and finally whether these measurements are actually feasible. The bill has three major desired outcomes. First, lower electric usage, and in particular usage of electricity from fossil fuel sources, particularly natural gas. Related to that, it hopes to lower the emissions that are associated with electric generation within the state, and finally, to increase the production of electricity from renewable sources. These outcomes can be measured by taking a baseline measurement of the values prior to the implementation of any projects, and then measuring these same values after projects supported by the bill have been implemented. And ideally, when making this comparison, you would see that all three outcomes, desired outcomes, had been met. That is, lower electric usage from fossil fuel sources, lower emissions, and higher renewable generation. Unfortunately, all these measurements are currently feasible and actually already done in the state. The electric usage at a facility level is done with an electric meter. While emissions are not directly measured, They are calculated based on the fuel source used to generate the electricity and known emissions factors which are established through scientific studies. And the generation of electricity from renewable energy is also measured with an electric meter at the generation site rather than at the consumption site. While all of these are all currently measured, some efforts would need to be taken to attribute any changes to the projects implemented from the self-direct program. So in conclusion, electric generation from fossil fuels, especially natural gas, have negative environmental impacts. This bill proposes a self-direct program that would incentivize large energy users to implement renewable energy and energy efficiency strategies to help minimize these impacts. And the bill's success could be measured through lower electric generation usage from fossil fuel generation sources, lower emissions from electric generation, and an increase in renewable energy generation. Thank you all for listening, and I'd be happy to take any of your questions.
Excellent presentation. Thank you so much, Tavo. So one thing that the bill leaves me wondering, or your description of it, is that energy efficiency requires distribution as well as production. And when you had that graphic of the transformer up, I was wondering whether the bill calls for like a retrofitting of the grid or any improvements to the distribution system that leads from production to user.
This bill does not specifically address that. The bill focuses, as I mentioned, specifically on the energy usage of these large energy users. I believe there are other programs in New York. As I said, New York is really working to change its electricity system, and so I imagine that those issues are addressed by other programs. This bill in particular just focuses on these large energy users and the measures that they can take specifically to improve the electric usage.
So you mentioned that this bill, one of the solutions is to encourage more renewable energy generation, and since renewable energy is an intermittent source of energy versus natural gas, which is a constant baseload power, does this bill talk about increased energy storage options while also increasing renewable energy generation?
It doesn't specifically address storage, I need to go back and check it. I think it might mention storage as one of the promoted technologies as part of the solution. Now that you mentioned, I think it actually does. It doesn't get into detail, but it fits in with the kind of distributed energy resources. I think storage is included in that.
Great job, Tavo. On slide 10, you had the graph with the different forecasts. I'm curious why the forecast without...
Oh, not that one.
Sorry, that one, yes.
This one, yeah.
Why it's such a sharp increase when it's been trending down without the effects of energy efficiency?
I'm not entirely sure. I'd have to go back at the report that this came from to see. If I had to guess, I would say that the decrease that we've already seen does to some degree incorporate these strategies already. And so that forecast, as it says, without the effects of the energy efficiency distributed energy resources would kind of, shows that these strategies already have been having an impact. That would be my guess.
Thank you.
Thank you very much.
Thanks.